for isochronous transfers. Okay, we are going to see what are all the special things we have to consider for isochronous transfer. We know that the difference between wired USB isochronous and wireless USB isochronous is what? In wireless USB isochronous we have retry mechanism, but in the case of wired USB we don't have that retry in isochronous. If you look at this diagram, you will get how the service intervals are allocated for the isochronous transfers. See, this kind of box indicates the start of frame. Okay, start of frame. We know that the length of the each frame is 65 millisecond. Each frame is made up of media access slots. In a single frame, how many media access slots will be there? 256. Okay, okay. So this indicates the start of frame. Okay, and then this is reserved for device A. This kind of shade indicates reserved for device A. Okay, now the largest gap between the service approached 2 frames. So this is the first frame, second frame starting, third frame starting. Okay, so in this first frame, here it means frame number n, it allocated some bandwidth for device A. Okay, in the second frame it has not allocated. Getting? Again in the this is the second frame, right? This indicates the start of the frame, second frame. It has not given any it has not allocated any reservation in this frame. In next sorry, yeah, it has allocated, right?
Allocated in end.
In the at the end, right? Okay, so in the next third frame it has allocated the isochronous transfers in the starting, right? Now what they are telling here is the largest gap between the service approaches 2 millisecond, I mean 2 frames, right? We know that in full speed what is the length of one frame? 1 millisecond. So it has started here, and 2 frames is equal to 2 millisecond. So it has approached 2 millisecond, right here. Okay, the smallest gap between the service approaches start of frame plus guard time plus reservation size. So in this slide they have shown both the things, largest gap and smallest gap of the service interval. Getting? This is largest gap and the smallest gap, like this. Do you have any doubt in this? What?
Reservation for each transaction is
What? Here. No, now we are going to consider only about isochronous transfers. Okay, so for that, what is the largest gap? What could be the largest gap? What could be the smallest gap? They've shown those things. If we'll in forthcoming slides we are going to see in detail. Okay. Next, see. Same we are having 3 frames here, frame number n plus 1, n plus 2. Okay, and that this diagram indicates the typical service interval for full speed isochronous endpoint. Okay, full speed. Now we are going to consider full speed. Here the reserved, this is the start of frame, this shade indicates start of frame, and reserved for device A. Okay, so the gaps between the start of service are all close to 1 millisecond. This is a typical service interval. See here, in every frame we are getting the service period, and it is close to 1 millisecond. Almost it is 1 millisecond. The gap between the service interval is 1 millisecond, right? You come to here. this is what, this is frame number 1, this is frame number 2, frame number 3. Okay, this is a full speed frame. Each frame will have the time duration of 1 millisecond, and 1 millisecond frame is divided into 8 parts, and each microframe will have the duration of 125 microsecond in the full speed, right? Okay, now here what's happening, the gaps between the start of service can be approached to 256 microsecond, right? And the gaps between the start of service are typically to 125 microsecond. Just look at here, this is a whole structure. In this we have 3 frames. Okay, 3 frames. Here here the service interval is here, host has allocated some period for servicing. Okay, and in the next microframe it has not allocated anything, right? At the end only it is allocating, getting. So the gap between the service here is 256, 2 microframes, that is nothing but 125 into 2, so 256 microsecond, like it will come around 256 microsecond. Okay, but if you look at here, it is service, it is giving that service interval at every microframe, that's why the service interval is 125.
Only starting frame in frame n. It's only.
No, it's not like that. They have simply mentioned the random number n. It could be 2 or it could be 10, like that. You don't consider this is a first frame. That's why they mentioned n, right? So the indexed frames or microframes provide a bus clock. Isochronous streams can be specified to start in a specific frames. Typically, the data that is produced in frame microframe x-1 by a wired isochronous in device is sent across the bus in frame x. A typical wired USB isochronous endpoints needs only 2 frames, that is 2 microframes of buffering. Getting for example, one wireless device wire adapter is there. In its downstream we will have wired USB device. Okay, so if it is producing the data at the x-1 frame, okay, x-1 frame, okay, and the same data will be sent to the host by the wireless USB device at the frame of x.